Indy528. This is the work we are proposing on IEEE Mass 2022. With this research, we proposing federated learning, uh, machine learning model tokenization uh, system with non-fungible tokens and model cards. In here, we trying to represent federated learning machine learning models as non-fungible tokens and gave a way to uh, buy and sell these machine learning models by using NFT-based marketplace. That's the main research contribution with this work. Let's look at more information. These are the authors of this work. I am Eranga Bandara. First of all, I will give a bit introduction about me. I'm Eranga Bandara, currently working as a senior research scientist at BMAS Virginia US. I'm involved with various research on blockchain, distributed systems, cybersecurity, privacy preserving AI, mainly angle with federated machine learning. And recently we have quite a lot of work we have done with 5G, 6G research. One of our main motivation of doing research is we always trying to do research and apply this research into real world production applications. Uh, Indy 528 is one such system or platform that we have designed and developed based on our research work. This is me. I am available on Twitter. If want, we can contact via Twitter as well. Okay, first let's look at some background information, mainly some information about federated learning and non-fungible tokens. Let's look at things about the federated learning. Federated learning is a decentralized machine learning system. It can be identified as a distributed machine learning system, which is designed to address the privacy issues of the centralized machine learning systems. Mainly in machine learning or any machine learning system or federated learning system, transparency and provenance are important aspects since the output of the machine learning results would impact to people's lives in various domains. Main concern of existing federated learning system is most of the existing learning systems, federated learning systems, deal with centralized coordinator. Coordinator is the party who uh, do all the coordination of the federated learning process to uh, model averaging, distribution of machine learning models, and a lot of functions. That's a core part. The main thing here is since the coordinator is centralized, it's vulnerable to attacks and privacy breaches. Uh, Also, that existing predatory learning systems do not provide any standard transparency and provenance mechanism for result in the models. That's another major concerns. Non-fungible tokens or NFTs. If you talk a bit about the NFT, non-fungible tokens are used to represent the ownership of unique items. Items could be most of the time digital items. It could be physical items as well. The tokens are unique and cannot be replaced with something else. So that's what it called non-fungible tokens. In here, there's another type called fungible tokens. Most of the time, cryptocurrencies are fungible. That means all the tokens are equal one to another in fungible tokens. But in non-fungible, so tokens one to another are different. So that's the thing. NFTs are securely stored on blockchain-based decentralized storage. The most common format to used to represent the NFT token is ERC721 tokens. The things happen is we encode the data or NFT token data into ERC721 format and stored on the blockchain ledger. Once it saved on the blockchain ledger, it is technically difficult to modify or change the ownership of the record, and also hard to duplicate a new NFT token. That's a feature we get through the blockchain. So that's the thing. Currently, NFTs are used to tokenize objects such as arts, collectibles, even physical things like real estates. If we look at more details about NFT tokens, so some funny thing here. NFTs are currently used to for most of the time fancy things. You know that most of the time people buying and selling JPGs as NFTs. I think this is kind of not a usable things, but the concept of NFT is really powerful. It can be used in more valuable and usable use cases. Uh, in here with this research, what we're trying to do is use NFT token for more valuable use cases. We propose an open platform called Indy528. It utilizes NFT token to represent the federated machine learning models. So these are detailed objects. So we represent federated machine learning models as NFT tokens. Then once we represent machine learning models as NFT tokens, we propose a concept of NFT-based decentralized marketplace for federated machine learning models. Federated machine learning models. In here, then training parties who can involve in the training and training stage of the machine learning models can build NFT tokens uh, based on the trained machine learning model and publish in this marketplace. Then anyone can buy these machine learning models. Then via paying fiat currency. Then the revenue will be shared among the parties who involved in the federated machine learning process. So that's the high level idea. That's the thing. So currently NFTs are used to most of the time fancy thing. So that's what some quote I have seen. I gave you Bitcoin. It's a quite powerful things, but most of the time what people do is uh, you vote some shit coins and JPGs. So that's the thing. Not a not much useful things. Currently people doing with NFTs. That's the thing. Most of them they used NFTs to buy and sell JPGs. Oh, quite no point. So that's the thing. Okay, now let's look at our contribution of this research. We propose blockchain-enabled coordinator-less federated learning systems. We can get rid of centralized coordinator-based federated learning system. The machine learning model, parameter sharing, model training, averaging functions are implemented on top of blockchain smart contract. Added more transparency and provenance to the federated learning process by storing the machine learning model information on the and reports in the entity called model cards. All the machine learning related data we encoded into the model card and stored on the blockchain ledger. That's the thing. Uh, in here, we provide some mechanism to integrate the machine learning models with the blockchain smart contract to real-time predictions. Main important thing is we propose now NFT token schema to represent the machine learning models as NFT tokens. Uh, by using this novel NFT token scheme, we propose a concept of NFT-based decentralized federated learning model marketplace. As a use case of these federated learning systems, we built some machine learning models to detect IoT device attacks in network sliced environments in the 5G. In here, we use this federated learning, design federated learning systems to build some models to detect the uh, uh, anomaly data of misbehaving IoT devices on 5G network sliced environment. I will talk more details in coming slides. Let's look at the architecture of the system. So we build the system as a layered system. There are 5 main layers in the system. Blockchain storage layer. It stored all the data on the system. That means normally in federated learning, there are multiple peer parties involved in the system. All the parties' digital identities we stored on the storage, and machine learning model related data we stored on the blockchain as model cards. Data provenance information we stored on the blockchain. Then smart contract, all the functionalities on this Indy528 platform handled with the smart contract. Identity contract handle the identity registration and identity related functions of the PS. Model contract handles the federated learning, machine learning, model generation, training kind of functions. Trading contract handle the machine learning model trading functions based on NFT. NFT contract handle the NFT token generation based on the machine learning models. Then federated learning layer, each peer in the system have their own federated learning system service which capable to build the machine learning models, federated learning models uh, with the data on their local storages. Model card service layer, uh, in each PA in the system have their own service called model card service, which do the model card generation. It is the place where we handle the data provenance. NFT service layer, it handles all the NFT token generation functions related to the machine learning models. Okay. Now look at the functionality of the system. There are five major functions in the system: identity registration, training pipeline initialization, local model generation, global model aggregation, and NFT model trading with NFT, basically NFT based model marketplace. First one is identity registration. As I mentioned previously, multiple peers are collaborate in the federated learning environment. It's a distributed system, decentralized system. Each peer in the system can deploy their own blockchain node. That's the idea. Then when deploying a blockchain node, that means onboarding peer to the system. This peer's identities need to be onboarded to the system. That's the identity registration. Training pipeline initialization in federated learning. So first training pipeline need to be initialized. That means initial model will be generated and decide the model parameters and all that. That's the training pipeline initialization. Uh, First, the ML pipeline needs to be initialized with the model parameters. Then what's happened is it, initial model will be distributed to the other peers. Then each peer will train that model with their own local data set and generate a local model. We call it local models. Then these local models will be sent to the aggregator or coordinator. Then coordinator average these local models and generate a global model. This process can be happen. It's an iterative process until getting a better global model. We do repeat this operation. That's the idea of the federated learning. In here, in training pipeline initialization, uh, in Indy528 federated learning environment, the training pipeline initialization will be done when generating the initial block. We call it Genesis block. So that's the thing. Mainly training pipeline contains initial model parameters, participating peer kind of information. In here, the main thing here is the initial block will be generated by the leader peer who choose by the blockchain consensus algorithm. In each iteration, there's no any centralized leader, but leader can be changed. So there will be leader. This leader will be chosen based on the blockchain consensus algorithm. Let's look at some more details. So assume there's a 5 peers in the system. So each peer have their own data. We call it off-chain storage. This is the place where we store the real data. So machine learning models will be generated based on the data stored on the off-chain storage. Assume in given iteration, peer is selected as the leader. In that case, leader will generate genesis block with the model parameters and model initial model and the model parameters. Then once generated the initial model, that model will be published to the ledger. So then other peers can be take that initial model and train that model based on the data on that or off-chain storage. Now let's look at the local model generation. Uh, Peers train local model according to the training pipeline with the data on the off-chain storage. Build model and model information are saved in the blockchain ledger as the model card objects. Basically, model card objects is the data provenance, facilitate the data provenance of the machine learning models. In here, the model cards stored basically uh, all the end-to-end steps happens in the federated learning process. Basically, it can store participating clients who generate a local model, who average it, and also quantitative analysis can be encoded to the model cards as well. This is how it's look like local model generation. Each peer, so get the genesis block published by the leader peer and extract the model parameters. Based on the model parameters and initial model, they train that model with the data on the option storage. Then they generate the local model. The generated local model data, basically model parameters or any data of that model are encoded into the model cards and published to the ledger. Then that's the local model generation. Then global model aggregation. Once all the peers in the system or majority peers of the system generated their local models, uh, the leader peer take that local models and average that local models into the global model. That's the global model generation part. Then it called final model. The final model data also encoded into the model card and saved in the blockchain. Then finally generated block will be broadcast to other peers in the network. This is how it's work. So once all the peers generated the local model, so leader peer fetch the local model information from the ledger, then average the local models into the global model by using any local model averaging function. Then it generates the model card based on the model informations and publish that and generate a block with the data, actually model card information, and publish that block to the blockchain ledger. Then other peers can take the global model from that block and use that global model stored on the block. So that's the idea how we design the federated learning system. If you talk more about the model card objects contains the model information. Basically, it's a data provenance systems for the machine learning. It comes with the TensorFlow model card toolkit. Basically, model card object can store any data related, provenance data related to the machine learning. Basically, participant clients who generate models, who average it, any information can be encoded. Then also quantitative analysis can be encoded into the model cards. So this is some example model card we have generated based on the IoT device attack detection scenario previously, as I have previously mentioned. It can contain model details, considerations, and quantitative analysis. Any data can be encoded. So that's the idea. Now let's look at the interesting part. So new NFT tokens. So that's the uh, place where we incorporate non-fungible tokens to represent machine learning models. In here, we have designed novel NFT token schema to represent the machine learning models. So this is the special NFT token schema, which mainly align the requirements of the machine learning model related data. Basically, NFT token contains information about the metadata of the machine learning model, URI of the model, ownership of the model, kind of thing. So this is the JSON encoded format of the I528 scheme. In here, the peers who participate in the machine in the model training are identified as the owner or contributor of the model. This information encoded into the JSON, as I mentioned previously, and stored on the blockchain ledger. So that's the thing. This is the way we represent machine learning model as an NFT token. NFT-based federated learning model marketplace. In here, uh, as a use case of I528 schema, we built some NFT-based marketplace, call it Indy528. We propose NFT-based decentralized marketplace to create machine learning models. So that's the novel approach we are proposing. In here, model creators and trainers can build and train federated machine learning models and publish them in the marketplace as NFT tokens. Then parties who want to use the models can buy them from the model creator as the NFT token by using fiat currency. Then the revenue generated by the transaction will be distributed shared among the model creators and model trainers. That's how we have designed it. The ownership of the machine learning models are encoded into NFT and saved in the blockchain ledger. So we have supported that feature. Now let's move to the implementation. So how we have designed the system. We have built some uh, production grade system, so like real world system of this Indy528 platform. In here, I have mentioned that we have incorporated the system into the uh, uh, 5G use case. So this is the way we have designed that. We have designed these systems as a decentralized blockchain based system. Platform implemented on top of Rasa blockchain, which is a highly scalable blockchain system for enterprise application. So it's another research work that we have done in the blockchain area. The smart contracts of the system implemented on top of Rasa blockchain plus smart contract. Federated machine learning service implemented with the PyTorch and PySwift based libraries, and model car service implemented with the TensorFlow model car toolkit. Apache Kafka used as a message broker of the platform. We deployed this blockchain system by using Docker Kubernetes based container orchestration system. That's the implementation details. Now let's look at some use case. So I have mentioned that we have designed some 5G based, we have incorporated this system into the 5G based use case. We have designed, we have incorporated this in the 528 system, machine learning models, federated learning system in the 5G domain. In here we design machine learning model to detect the IoT device attack scenarios in the 5G network sliced environment. In here, this is the 5G test bed that we have used to in this application scenario. In here, we have used the 5G test bed called Freedom 5. Freedom 5 is the some decentralized 5G network where we can set up 5G network with low cost. We have purchased this Freedom 5 from the vendor, and we have set up on our lab. So this is the 5G core, and this is the 5G radio cell. In here, Freedom 5 comes with their own SIM cards where we can put into our mobile phone. Then we can connect to this 5G network. Then what you have done is we created a mobile hotspot by using this SIM card. Then other IoT devices, for example, Raspberry Pi is connected to this uh, Wi-Fi hotspots. Then they can communicate the packets through this. So that's how we design our test bed and use the that test bed to uh, test the machine learning scenarios, predictive learning scenarios. Okay, that's it from my side. If you have any questions, we can discuss them now.